Hi, I'm Paras.
I'm Sid.
I'm Ria.
I'm Avi.
I'm Manish.
We are St. Francis C.
Our project aims to confront the issue of seasonal and chronic depression through photic and audio stimulation. These forms of depression have traditionally been treated with regular doses of drugs, such as mood stabilizers or antidepressants like serotonin reuptake inhibitors. Depression has also been treated through psychotherapy, where therapists assist patients with cognitive behavioral, interpersonal, and problem-solving therapy. Unfortunately, psychotherapy is not effective in resolving severe depression, and usually must be paired with prescribed medication. The reign of antidepressants has gone generally unchallenged since the 1950s. However, recent years have witnessed the birth of potential replacements.
One promising candidate is phototherapy. Light therapy has been used to treat seasonal affective disorder as a potential alternative for those who are unable or unwilling to take traditional antidepressants. Recently, researchers have studied the effect of photic stimulation on alpha waves, which have been linked to depression. One study done by the Korea Advanced Institute of Science and Technology studied the impact of photic stimulation on the depressive symptoms of mice. The study concluded that flickering photic stimulation more rapidly improved behavioral outcomes in a mouse model of depression compared to the antidepressant fluoxetine. Another case study by Dr. Kumano exposed a patient to photic stimulation in order to stimulate alpha waves. The treatments brought about an improvement in general mood state and an increased alpha rhythm. It was concluded that the alpha enhancement caused by the EEG-driven photic stimulation helped decrease the patient's depressive symptoms.
We were able to graph the data we received through the EEG headset with a program in Visual Basic created to interpret raw data. On the leftmost monitor, we can see the average relative intensity of Avi's brainwaves as we take baseline control measurements. This average moves less and less as more data is recorded, eventually stagnating to the point where we write it down. The app also allows us to graph minute changes here as well. Here, Avi is wearing the EEG headset as he works on a strenuous task. In the next test, we will observe Avi's brainwaves in response to the spatial therapy provided by the Oculus Rift in virtual reality. Avi is now wearing the Oculus Rift, a virtual reality headset which we have programmed to display a calming canoe ride. As he explores this virtual world, we play soothing melodies as an accompaniment.
In our experiment, we used a virtual reality headset, headphones, and an electroencephalogram to fully immerse the subject in a virtual reality experience. Our goal was to increase alpha wave values and thus reduce the symptoms of depression. The virtual reality experience consisted of a program that simulated a calming environment. Measured alpha waves were compared to those of baseline and high-stress situations to determine the success of our treatment. Our results showed that the treatment was effective, at least in the short term, in increasing alpha wave values.